Okay, so let's try to solve this problem 3 sum. Okay, so the problem said given an integer array nums, return all the triplets nums I, nums j, nums k such that I not equal to j, j not equal to I not equal to k, and j not equal to k. So indexes should not be same, but we need to find triplets. And if we sum the triplets nums I plus nums j plus nums k, then we will get 0. Okay. So notice that the solution set must not contain any duplicate triplets. Okay, so for example, I cannot have -1 0 1 again. Again I cannot have -1 0 1. Okay, so this we should not have. So we should not have duplicate triplets. Okay, so and if we see the constant, so it's like 3000. So I mean, based on the constants, I think we can go with an work in square solution. Okay, all right. Okay, okay, okay. So I mean, look at this example. If you look at this example, so -1 0 1 2 -1 -4. So if we find the triplets, so you can see like -1 0 1, and another one is -1 and 2. Okay, so I mean, if you want to go with the brute force approach, okay, so then I can think I can take 3 loops, right? I can take I j k, and probably I need to like I can have a set data structure to remove the duplicates. Okay, so in that case, like, what will be our time complexity? So time complexity will be O of n cube, right? I mean, that's not what we expect. Okay, so what can be the better solution then? Okay, so let's say we'll fix the first element. So let's say we'll fix the first element. So let's say we have like this. Okay, so -1 0 -1 0 -1 0 1. Okay, so let's say we'll fix the first element. Okay, so we'll fix the first element. Okay, so the remaining would be 0 minus 0 minus this first element. Okay, okay, so then I need to look at the right. I need to look at the right. Okay, so I need to find 2 elements whose sum would be remaining minus this first element, right? I mean, that is referring to 2 sum, no? I mean, we can think of 2 sum, right? So if we fix the first element, that if I on the right, whatever the elements we have, if we get a 2 sum, okay, I mean, we already solved it. Okay, if we get a 2 sum, then we will get 2 elements. Okay, we'll get 2 elements. Okay, and we already have one first element we have already selected, right? So then we can get a 3 we can get 3 elements, right? So we can get a triplet. Okay, so in that case we'll get a triplet, and then probably we'll figure out something to remove the duplicates, right? I mean, that's not a big deal. Okay, so let's try to do that way. So let's say I will first and to handle the duplicates, so let's say I will have -1. So I can have like -1. So let's say I am getting the results like -1 1 and 0. Okay, and then again I am getting like, okay, -1 0 1. Okay, now I mean, probably if you sort it, right, I mean, you can sort it now. -1 0 1, and then another I can get -1 0 1. So if we sort these particular triplets, then we can and if you add these triplets to a set data structure to remove the duplicates, then we will get all the unique triplets, right? All right, I mean, we'll figure it out. Okay, so let's say we'll declare the length of the nums array. So length of the nums. Okay, next what we will do? So we'll run a loop for I in range n. Okay, so it will iterate all the elements. Okay, so this is just to take the first element. Okay, just we are picking only the first element. So we are picking one first element and then compare on the right. Then we are picking on the first element, then compare on the right. So we are searching for a two sum on the right. Okay. So over here, so for I in range n, okay, next what we will do, so we'll find two sum. So find two sum, okay, on the right. So for that we need to run a loop for j in range. So I've already take already taken the first element, so we cannot take the first element again, so we'll move from y plus 1 to n. Okay, next, so then what will be the remaining? Then remaining would be sorry, there is a spelling mistake. Remaining would be 0 minus nums of I plus nums of j, right? Okay. Okay, so this part I think we have already done it. Okay, so then we'll see in two sum we have taken a hash set. Okay, but here we don't need to find index. Okay, I mean we taken a hash map, but here we don't need to find a don't need to find a index. So we can just simply take a set over here, set data structure. So already seen. Okay, so this is a set. Okay, and as usual we'll add this already set when you are iterating. We already add this nums of j like we did in two sum over here. Okay, and over here we'll check if remaining in already seen. So this remaining in already seen, then what we'll add, so we'll take a result set over here. I mean at the end we need to store it somewhere, right? All right, so if remaining in already seen, then what we can do, so then triplet would be what will be triplet? So triplet will be nums of I already seen it. I mean, you already seen it. So then I can get the triplet, right? Like we did in two sum. Okay, so two sum. So this particular remaining whatever we have. So this remaining we already seen in this already seen set. So then I mean we got our two sum, right? So then you can store in the triplet. So nums of I, this is the first element. Nums of j is the second element, and then nums remaining is the third element. Okay, hope the spelling is fine. Okay, so remaining is the third element. Then as we discussed before, right, to remove the duplicates we need to sort it. Sort the triplet. Okay, so we can sort it. So triplet sorted, so you can say this is sorted triplet. Okay, all right, next what I need to do. Oh, we have taken a list data structure. List will not work, so we need to take a set data structure because we need to remove duplicates. No, okay, so then what we will do, so then we will raise dot append, and we need to append as a tuple, otherwise it will complain. Tuple, then sorted triplet. All right, so tuple sorted triplet. So this is done, right? So we are adding as a tuple to remove the duplicates as a tuple. Okay, so first it will sort like this way. If you have got like minus 1 1 minus 1 1 0, so it will sort it minus 1 0 1, and then minus 1, so let's say this raised set is containing 2, so if it is a set, right, you cannot contain 2, so we are converting it to tuple. Okay, so that it will remove the duplicate, so we'll get minus 1 0 1. Okay, that's fine. Okay, all right, now so now what we have to do, we need to return. So for that, what it is expected, it is an array, so we need to return. So we need to convert the item because you have converted to as a tuple, so we can convert the each item whatever we have in this raised set. Then for item in for item in res. Okay, so this if you do, then I guess let's see if you have any spelling mistakes. Res rain, we have set data structure j in I plus 1, remaining we are calculating over, remaining already seen. So this already seen, you have done it. Triplet remaining, so nums of j sorted, we are sorting over here, and we can remove, we can just do one line over here, and just for understanding I have written in 3 lines. Okay, then already seen dot add nums of j, return list item for item in res. All right, so let's run it. All right, it's passing. Okay, so let's try to submit this, then what happens. Oh, oops, we got a TLE. Okay, all right. Okay, so let's take how to optimize. Okay, let's see how we can optimize. So let's take this example. Okay, so over here, so when nums of 0 is equal to -1, so we are taking this as a first element. Okay, then what triplets will get? So triplet would be minus 1 0 1, right? And then again, if nums of 1 is equal to 1 minus 1, again the triplet would be what? So we have taken -1, then what we have on the right? So 0 1, so again the triplet will be -1 0 1, right? So now see, like this two are duplicate, no, so I mean, and as because the first elements are same, like we already taken the first element, and that's why we have you see this in the second case you already taken this, in first case you already taken this first element, no, so this -1 you already taken in first case. Second case again we are taking this -1. Okay, so -1 we are taking, okay, because we already taken this first element. So if we check, like if we can check, like okay, if we can avoid like to take the same first element again, then we can optimize, no, I mean that's what it is happening over here also, because the first element are same. Okay, so it is creating 0 0 0 again 0 0 0 like that. Okay, so that we can do a optimization over here. So let's say we'll prevent it. Okay, so to prevent it we can have a set data structure. Okay, so already, let's say already taken. Okay, set already taken already taken as first element. Let's say I'm probably this is a big variable, but fine, just for understanding. Okay, so what we will do, if nums of I not in, so we have already, if you have not taken it as a first element, then only will go proceed, right? Not in the already taken as first element, then we'll do the rest of the operation. Okay, and so over here, and then we need to add it also. So if you have taken it, then we need to add it also. Add this already first element dot add this nums of I. All right. All right, let's run this. It's passing. Yeah. So what will be the time complexity for this? Okay, so time complexity, so you are running two loops over here. Okay, so that is O of n square, and we are also having a set data structure to store it, and that we can probably calculate. Okay, 3 elements we are storing. Okay, so number of triplets, the number of triplets we are storing into this raised data structure in this set, so that will also have some space complexity. Okay. um, all right, next we will try to find the, we need to write the test cases also. Okay, so I mean this optimization part we already done it, so I will not repeat it again. So I mean you can think of this basic example we can take, so you can expect that that is my, will have all the unit triplets. Okay, next is like all positive numbers. So if you have all positive numbers, let's say 1 2 3 4, I mean it is monotonically increasing order, so it's an increasing sequence. Okay, so then probably we'll get expected would be expected would be a empty array, right? Empty set, empty array. Okay, then if you are having uh, empty array, so let's, if you are taking that empty array over here, then also it will get, will get an empty, expected would be empty. Then stress test, so let's, we will have very big large list. Okay, so how it will perform, that also you can check, like we can have like list range of minus 1000 to 1001. Okay, and then you can check. Okay, next is all zeros, so if you are having like all zero elements, okay, so or more than three zeros, then we can expect that we'll be having only three, only one unique triplet. Okay, then let's say we are having all negative elements. Okay, so then also we'll have only then we'll also not have any triplet. Okay, in cases like where you will be having like mixed duplicates. Okay, so mixed duplicates say like -1 -1 0, so let's say mixed duplicate. Okay, like we have seen over here, so then we can expect only one single triplet, this is -1 0 1. Okay, then if you are having less than three elements, so I mean we are about to find triplet, right? So if you are having two elements, then what will be the expected? So it will be expected to be an empty array only. Okay, all right.